Let's move to the next question. This question is based on mechanical energy conservation and the vertical circular motion. To be clear, let me draw this diagram again. So the diagram includes a path like this. A block of mass is released from a point simple h above the ground, above the horizontal ground, above the horizontal ground. So this height is simple h. This height is simple h. Also, the radius of the circular path is given as simple r. Simple r. So what is being asked in this question is, the block is released from A and it slides without friction and without rolling. So there is no frictional force. Also, there is no rolling. That means we don't have to consider the rotational motion of this block. There is no rolling and there is no friction. The block will complete the loop if h. So we have to find the value of h such that this block will complete the loop. So let me first use the energy conservation. Use the energy conservation. The block is released from this point initially at rest, but when it moves up to this place, it will considerably get a velocity of v. So if I just use energy conservation, mechanical energy conservation, let's use mechanical energy conservation. Mechanical energy conservation. The energy conversion that is going to be happen here is there is a slight increase in the kinetic energy. Also, there is a decrease in the potential energy, gravitational potential energy. So I will equal those two quantities, the increase in kinetic energy and the decrease in gravitational potential energy. Decrease in gravitational potential energy. The increase in kinetic energy is half mv square. As you all know, it's half mv square. The decrease in gravitational potential energy. So let me first find the height this mass drops. This mass has fallen down with the height h minus 2r. This height is h minus 2r. So if I write the gravitational potential energy, it's mgh. So the initial height I have to consider is h minus 2r. H minus 2r. So let me solve this quickly. So I get an expression for the velocity, that is square root 2g into h minus 2r. H minus 2r. H minus 2r. So now I have already applied the mechanical energy conservation. Now I just have to use some theory based on this vertical circular motion. Vertical circular motion. In any kind of circular motion, we have to mark the forces. We have to mark the forces. The forces that are basically marked here is its weight and its perpendicular reaction. Its perpendicular reaction. But the question is, the block will complete the loop if h is. So we have to find the minimum condition so that this block completes its full loop. So I have to take this perpendicular reaction to 0. Just imagine this situation. What will happen if this block suddenly comes up to this place and its perpendicular reaction suddenly disappear, it will just continue its circular motion. Why, am it already has a velocity at this point. Even though the perpendicular reaction is 0, it will complete it full circle. So if I consider this circular motion and use F equal ma, let me use F equal ma. So the resultant force acting towards the center is mg, because perpendicular reaction is 0, is equal to m into the centripetal acceleration, could be written as v square r. Let me simplify this quickly. So I get an expression v square equal gr, v square equal gr. So if I combine those two expressions, I have an expression for the velocity here. Also, I have an expression for the velocity here. If I combine these two, those 1 and 2 equation, I can get such expression. Here v square equal gr. Also here v square is equal to 2g into h minus 2r. If I quickly simplify this, I get an expression r equal 2h minus 4r. So 5 simple r is equal to 2 simple h. So h is equal to 5r/2. 5r/2. Right. Let's move on to the next question.